Hello. I'm Chris from Airwindows, and we're going to do some coding today. So welcome to the Monday coding stream, and folks might actually be kind of interested in this one because today what I'm going to do is not that hard, but it's fairly well anticipated, and that would be the ZLowpass2. In other words, it's the Z-plane style filters, the way that the original ones sound, but with the interpolation that I brought to the Y-series filters. So we might as well begin. And I may wait until I see anybody showing up. Hang on. Doing my usual fooling with the controls. Moving this down there so that I can see what it's doing. Excuse me. And there's our chat. That still looks the way it should. Let's just test that I have audio. Very good. Hey, Stephen. So yeah, we're going to be coding ZLowpass2. By the way, depending upon how things go, we may have a guest appearance. If I address anybody, it's because I have somebody with me. If you notice to change my mood from the plugin video of Paul Wide with plugin videos previously, it might have something to do with it. And let me see. I'm going to keep fussing with the windows as much as I need. Now let's begin. I keep wanting to check the, here, let me just fuss with the windows some more. Now I can see whether I've got it set up properly. That should be good enough. So here's how we're going to go about this. And I have my second cup of coffee for the day. Trying to find the cursor on the screen. There we go. I'm going to start with the audio unit version of it. And we're going to make a curious synthesis of Y low pass here. And Z low pass here. And we'll probably leave it sounding the same. As you might remember, opening up the audio program again, what we've got here is many plugins for starters, but this is the one where we've got the res edge control, and it has smoothed coefficients, meaning it's a fluid liquid sound when I manipulate these things. Whereas what we've got here this is the one that's designed to sound like the EMU E6400 sampler. So we can do similar things there. It also has poles, so we can get a more intense effect out of this guy. But what this doesn't have yet is smoothing. It needs to have coefficient smoothing. Hey Aaron, doing pretty good. So that we can manipulate these things and have the fluid effect that we want while still having this tone color. Because this tone color doesn't exist in ZLowpass. And that's our job for today. So we're going to merge these two guys in a curious way to produce what will be ZLowpass2. So at this point, I'm going to choose, like, which one do I want to start with, which is a fair question. I think I'll take pieces of each. Only thing I will know immediately is ZLowpass. My habit with these is I have to give it an ID, but I can't use the same ID. So what I typically do is I increment that last letter by 1. So elemental PQ, so ZLowQ. And then I'll be wanting to copy stuff over from here. All the stuff in the top of this is going to be exactly the same as the existing ZLowpass, but all of the filter stuff, all of the audio code is going to be quite different. So we're going to skip up here. Excuse me. And we're going to copy this stuff. That will go unchanged because ZLowpass2 needs to look, act, and behave exactly the same as ZLowpass1, so you know how to work with it if you knew how to work with 1. It's going to be a little more CPU intensive, this interpolating stuff. That will cause that to happen. There's no real way around it. So if you were using it as a fixed frequency thing, there would be no real benefit not just using the original one. That's why I'm keeping them both rather than replacing the original one with this new one. Also, people did have uses for like a sort of neurofunk thing, like turn up the resonance a lot and then slide it around a lot on bass frequencies and get a peculiar crackling. That's something that people can do on purpose. And let's start taking this stuff. We'll kind of take both and decide which we want. By that, I mean there's the initial burst of stuff, and then I'm going to reach into ZLowpass, and that has only one filter rather than the stack of filters that this one has. But ZLowpass has a single, well no, not a single, two different anti-aliasing roll-off filters. Excuse me. And this looks like it's ready to copy straight out of here. So what we're going to do is do that. And next thing to do, since we've copied that bit over, is go into some of this other stuff, and we can start doing these default things as well. This is not really done. We need a little more than this. In particular, I think we need 4 of these. B, C, and D. You'll note that's the same as what I've got up here. So we're going to end up taking this stuff away and sticking with only this stuff, because this is the final version of how the biquads work. They're documented a little bit better. They're using this enum. The enum is a list of things that just increment. It's like the real value of these variables is 0, 1, 2, 3, 4, and they're like fixed setup variables that are always going to stay the way that they are. I think you call that final. I believe enum creates variables kind of like that. They're kind of like final ints. And so you can refer to array things using this label rather than just using a number, which could be the wrong number. But the label is going to be correct even if I added stuff in the middle of here, which is why enums are nice for this. And we've got this, which is a fixed frequency. I'm calling it that. This comes out of ZLowpass with the interpolation, because we're not interpolating that stuff because that stuff doesn't move. That stuff stays the same, and these ones move. And we're going to be replacing stuff here because back when I did ZLowpass, we'll skip down to the bottom here, and you can see that this is what I was calling the fix low passes. I could really relabel those and just take the code from this and use it. I'll think of what I want to do about that. But we could simply take fix A and fix B and call it biquad E and biquad F, and it would do much the same thing. And the stuff that does is the op-amp stage, which is what makes the filter stop sounding as much like just a digital filter, and it makes it sound more like a hardware device. So firstly, this stuff is more or less set up at the moment, although I have a little cleanup to do. It will not compile under these circumstances, but we'll see where we can take it. This is showing me which of these aren't going to work, because we've got 1, 2, 3, and 4, and then there's 5, and so on. And I believe all of these are generic controls that are similar to what I would be using with the VST. And they go from 0 to 1, so I don't actually have to change any of these defaults. But I do have to take out these remaining ones because I don't have 10 of these. I only have 4. And now that's got this one taken care of. It matches with the previous one. And here we're going to have to do a little bit of work. So we're going to do the same thing of taking both of the versions and then using only what we need. So there's our original one from ZLowpass, and here's the equivalent thing from ZHighPass. And this is doing some of the stuff over again. Oh, Julian, you're quite welcome. You tried to understand the bit. Well, this is a good place, actually. Hang out with me here, and I'm actually going through the basics of coding, and the way that I code stuff is very approachable and not too abstract. This is C++, but the way that I code it, it acts a lot more like just C. And to the extent that I spot you talking in the live chat, ask me any questions you like, and I'll answer them as best I can. I'm here for you during this stream. I'll be walking through this stuff as I go and figuring out the bits that I need to do. But, I might be incorporating more from ZLowpass than I expected. I think I'm interpolating the gains also. And that is fine. Nothing wrong with that. But yeah, I've copied this over here. And then let us just say, here, I'll scooch this over so I have a little bit more room. Let's just say that we're going to use the stuff like this, but we're not going to take, but in fact we can't anymore, because here's the thing that I changed. Let me show you why I just said that. The new biquads, these are filters, are using all of these little parameters in here, and the fixed ones are using these. So the new biquads are using the parameters that let you do the interpolation. Those are all built in, so that if you say long double biquad A, B, C, and so on, and use this format for them, and BIQ, then you'll be setting up arrays that contain all of this stuff. But the ones that are fixed are much smaller. There's not as much going on. Oh, in some ways I'm an absolute newbie too. Don't worry about it. And so the ones that say fix use fixed total instead of biquad total. And that turns out to be a different number. If you count up from these, it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, like 22. So this is the same as going long double biquad square brackets 22 and square brackets. And it makes an array that has 22 items in it. Whereas this one goes like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so what this ends up meaning is fix A square bracket 11 square unsquare bracket. So these are different sizes, so we can't actually leave the other thing I was talking about the way that it was. I just deleted stuff out of this loop. Actually, what I'm going to do is I'm going to take everything out of this loop and put it somewhere else. And I'll tell you why. ZLowpass has the interpolation, but it only had one filter. The Z-plane filters, or the imitations of them, have 4 stacked up. So we're going to use this to do that. And instead of going up to 11, these go up to like 22, because it's all the interpolation stuff I was doing. And the fixed ones can stay named fix A and fix B, because I think that's a useful way of distinguishing them between the ones that are smoothed, the ones that do the interpolation. And I'll tell you what interpolation means in a moment. Firstly, I don't need this because this is doing the same as that. And the reason I wanted to keep this is because this counts up to biquad total. And that's just a neater way of going about it. I probably don't need these numbers, pow factor, but I'll look into that later. Like if this is confused enough and I don't know what I'm doing, then when I try to build it for the first time, it won't build, and I'll figure out what went wrong. But for now, we're going to just kind of walk through all the logical steps that I might choose in order to get this working. By the way, also, if you were a newbie to C or C++, the way I've arranged some of these things is sometimes weird. You might see stuff very much just, one line and then a semicolon is always the end of a line. I sometimes compact them because the way the C thing, it doesn't really care about lines so much as just semicolon means, okay, that's the end of this statement. The idea that we have just thought about is power factor equals 1. And so the computer decides to do that and then looks for the next statement, which is this one, and so on. And this for statement means keep doing this thing with the variable that we've just made here. It starts at this and it increments, and then as long as it's not less than, as long as it is less than this, do the stuff in here. And the stuff in here is the stuff inside these brackets, which is why it moved the way that it did. If you hit like return, you'll see that the way the brackets are arranged, it's all kind of indented. But if you hit return with this bracket, what you get is these are on this line, and then the for statement is stepping through these things and asking this stuff. The choice to make it a new line is a way to keep everything sorted, and you keep it sorted the way that you need to. There are coding guidelines and all different communities of people coding stuff. If you were working for somebody, they probably have a way that they want it arranged. And since I'm just doing open source and whatever I want, I can arrange it the way that I please. You can run everything together into one giant big line if you want to obfuscate everything. So one way of doing that is to set it up kind of like this, where you're going like, okay, for int, oh, hello. It just moved my cursor. And it's asking whether this is true. Is x less than biquad total, which is something like 22, remember. So if it is, it does the stuff inside these brackets. If there are no brackets, you can just move a single statement and it'll do only the single statement because it'll only do the one thing up to the semicolon and then it will stop. But if you have multiple things, you got to have the brackets. Those are what show you what to do each time. And once it's finished doing those things, like biquad A of 0 equals 0, B, same deal, D of 0 equals 0, and so on, it runs out the bottom of this thing and goes back to do the for statement again. And then it does this. X++ means add 1 to what x is. You could also have it say ++ x, at which point it would add 1 before asking this question. The logic question of less than means this is a logic statement. It's going x less than biquad total, and the answer to that question will be true or false. If it's true, do this stuff. If it's false, you don't do that stuff. In fact, I believe if it's false, you drop right out of the for loop, because the for loop is designed to repeat things. And then when you do x++, you ask this question about x, and then once you've finished asking it, you add 1 and then start over. And you ask that question again. Is it still less than biquad total? If it is still less than biquad total, go through and do this with the new x that you just made, which is now 1. Again, do it again, 2, biquad A 2 equals 0, and so on. You finally get to where it's like x is 23, or x is 22, biquad total is 22. So it's no longer less than, it's going to be the same as. Like if you had it say this, it would still do one more, but it is only less than. So when it's the same, it's no longer representing that. And so then you stop doing this and you move on and go, okay, pow factor A equals 1. Fair enough. Onwards we go. So I'm going to go and put this back to what I had again. Not that it's particularly graceful, but it takes up less space and I can see more of it on my screen. And it's just my little coding practices, whether they be like clean and tidy and appropriate, or just a very personal, crisp statement of how I like the page to look. You'll see I didn't run these all together. Instead, it's like pow factor A equals 1, pow factor B equals 1, and then on another line, in trim equals 0.1, imtrim b equals 0.1. They're kind of like each other, but they are, you know, they could be all in their own lines. They could be all run together into a clump. Hey, Focal, well, thank you. I will be moving onwards and doing ZLowpass with the same interpolation that Wide Stuff has today. So that should be exciting. And this should give us a good solid start on what we're doing with ZLowpass2. That's now initialized all these variables, which you got to remember to do. You can't leave them blank, because if you leave them blank, they could be anything. These are parts of an audio process, so they might need to start out as 0, representing kind of silence. If you don't do anything with them, they could be coming from, like, this one was previously a picture, a piece of some JPEG files pixel format somewhere, and read as a long double. Its value could be like 27 million, at which point you pipe that into your audio process and it makes loud screeching noises. So we go through and sort out that stuff as we go. And my next question becomes, which of these do I take first? Here is our process section. And right up at the top, we've got things like, this is where we get our samples from, and overall scale means what sample rate we're on. X can be anything that you like. Let me skip upwards here. So in this statement, this for statement, we say for int x equals 0, x equals 1, 1, and, you know, x plus plus, and then we've got this stuff in here. So the way that the statement works, it says this is an x. X here, let me go to the other one. Let's go to this. Let's go to the one that we're actually using. So int x equals 0. Well, right now we know that x is 0. But guess what? Supposing we go, assuming there was something that was like print, right? Or, you know, we could also go like intrim b equals x. Guess what would happen? And remember, this all was in this place where you do this thing, it repeats it, and everything within these brackets does something, and it knows the value of this x. It's counting up using the x, and we're defining it here. What would happen? This can't find an x anymore. The x only exists inside these brackets. After the brackets are done, we've forgotten what x meant. Or by the same token, if we've got this stuff here, and we say, okay, x equals 0, cool. Let's just take that, or we'll count it up to 22 using this for statement, and then let's make intrim b equal 22. Let's use x, because we just had x being 22. In fact, when we did this question, this logic question, saying x less than biquad total, which is 22, at the point that we stopped, that's because x equaled 22 rather than being less. So let's use it again. Well, no, because by the time you get to here, the computer has forgotten what x was. It only lived within this space and this space that defined what it was. And once you were done with that, x goes away again. It gets even worse than that, like I think it is possible that you could do this, stick this in here. It says float x equals 0, 1. So that's not the value of a fader. I'll show you where the values of faders come from. But you can do this, and then you've done this, and it says, oh, hey, this also too is x. But guess what? It's a different kind of x, and it will probably get confused and have a problem. But when you've defined this x out here, either you can't define this one as x and you need to pick some kind of other other variable, or it like passes through and this one becomes the value of what you told it to be out here. It's in a different scope rather than, and then if you expected it to be what was inside here, that doesn't actually work, because that x stopped existing once this part ran out. So let's step through some of this stuff. So right now what I'm looking at is a place where these are where we get the value of the faders, because in the audio unit, in the generic audio unit, inside this place, process, you can say get parameter kparam1, and that's your first slider. Not necessarily a fader, because this is a plugin. It might not know what the faders in the DAW are doing. But the sliders in the plugin talk with this language. And in fact, up here, we're able to talk a little bit about how that fader gets its values. For instance, in the audio unit, we can tell it that the values go from 0 to 1. Or we can tell it that the values went from 0 to 10. And then that fader would give us numbers from 0 to 10. And the default value would be whatever we told that it was, param1. And then we can read it here. Every time we go into this place, process, we can ask like, okay, this buffer of samples that we're going through, where's this knob set to? And you use that. That said, what we've got right here is just placeholder stuff. It says remove this to use these controls. These things aren't actually relevant to what we're going to be doing, and this stuff isn't actually relevant to what we're going to be doing. This is default placeholder stuff. So what lives inside the plugin is a bunch of code inside this place. And some of the stuff that I've got here is just additional things I have working to help the audio work and take care of various things. And what we might look to do is copy over from the other plugin, one of our sources. Here's a bunch of stuff about how we tell this to do what it does. As you can see, I've got my overall scale stuff here. I'm going to go through and copy everything all the way down to when it says while n sample frames minus minus. Remember where it said for x equals 0, and then there is a logic statement with one of these operators that's a logical operator? And so it's asking a question, and the answer to this is going to be true or false. The while statement is even simpler than that. It is while this is larger than 0, the answer is true, and we do all the things. When it stops being true, we finish doing all the things, and we're done with this particular part of code. So let's copy this for starters, and let's paste it into this place. So that's where that goes. Some of this stuff is represented in what I've set up. Like I've got biquad A, it does the same things, although I am probably going to update some of that stuff bit by bit as I go. I'm merging two different kinds of programming here, and I'm going to want to take, like, this is not necessarily labeled correctly. That's stuff that I'm going to have to bring up to date. And let's also take the code inside here, because this is going to be our, hey, Anonymous77, this is going to be our audio code, And we're going to kind of run from here. Let's go from including the double dry sample. We'll make it long double though. I was just talking to, oh, and we're going to also want to not include this because what I currently do is slightly different. And we're going to go all the way to this place that says begin 32-bit floating point dither. The surge synthesizer actually doesn't use those parts. They only just recently went through and deleted it. And I believe that, yeah, we'll... So now what we've got is a system where if I do a couple of changes, I should be able to build and have a working original ZLowpass, and that might be worth doing. Maybe we should try to do that. First, I'm going to check and see whether ZLowpass, so I shouldn't have actually changed that. So what I'm going to say is, oh, save files before closing. I'm going to say no, don't change it. I think I must have edited something while talking about how things are done. We don't need to save that. That was the previous one, and there were no changes that I should be making in it. It should stay the way it was. This is the new one. If I was to close this, I would want to save the changes. And this is the interpolated stuff that I'm going to be bringing this up to speed with. So first things first. Here is, so the way this is working, I'm going to be updating it, but I think it will probably work as is. It'll just have a little extra space because this definition of these is a little bit larger than what I had, but that's harmless. I don't have all of these, but this is the same as this was because fixed total is the same as the way this started out. And we're just going to rename biquad E to fix A and biquad F to fix B. So we can do that, I believe. Let's be looking at that and a little find and replace work, I think. So, oh, it just jumped all over the place. No matter. Up. So I want to change all of these to say fix A, if I'm not mistaken. Yep, I'm going to want that to say fix A. All this stuff here, and then also down here, needs to have the new value. And then square bracket, that doesn't include everything, but it should update all of this stuff. There's no biquad E anywhere else that I need to worry about because it's not supposed to be there. So it's not changing anything up here. It's changing stuff in here. And then biquad F, that we've also got, needs to be changed to be fix B. And that also changed stuff in here, which is what we wanted. That was supposed to happen. Now, if I don't miss my guess, I can probably compile this. I'm going to put this back first. There may be some things in here like this POW factor, but if I defined it and told it what value it was and then just never use it, that's pretty harmless. So let's see if this will compile. It probably won't, no, it won't the first time around, because a quirk about the way I'm doing these is that it's trying to compile AU source, but it needs these to be compiled too. And it's going through, it's throwing all those errors, and then it's going through and compiling all the stuff in here. But it needed to have this done before it hit this stuff. It's just that it's in the wrong order. And that's silly, but that's also fairly harmless. All I need to do is compile again without changing a thing. And we have a conflict. So that's interesting. And we're going to find out what went wrong. This is what went wrong. I don't need this stuff here, but I do need this. So what goes on is, this is what I had in the header file, and I need to have this stuff be here, and the fixed stuff, it's fine. But up here, I was copying from this because that was the previous one. I can define these just fine because I'm not using them. I can define IIR sample A, and I'm going to be using it, but I can't define biquad A through D twice. So we're going to delete that, and then although we're not using these, we're going to delete these too. I think it's fairly likely that that fixed the problem, but we'll see. Save. Look, the errors are popping up even though they don't mean anything now. And now let's see what we get. It may still be an error or not. And this time it was fine. So here we are. We've just compiled our plugin for the first time. It's going to eventually live there, but for now, this is where we had it. Open it up, go to the build folder. We've set it to be on release. ZLowpass2 component. And if this worked, that means that I run the software. This old version of macOS doesn't require that you reboot the machine when you give it a new plugin, so that's convenient to develop on. And here is our ZLowpass. And if we load up ZLowpass2, it should work and sound exactly the same because we haven't changed it yet. Assuming, of course, we set it to the same setting. I remember in working with this, I had to set it up so that there was a lot of output gain available, because it needs to also work with very little distortion. But since it is ZLowpass, it's designed to distort very heavily. And that's designed to sound like the hardware unit does. We went through a lot of trouble to get that happening. The point now is we're going to make it so that it's smoothed as well. So we've now just demonstrated that the thing that we compiled is working the same way that the previous one does. I only changed the names of some values, and I copied everything in so that it's supposed to be functioning. I don't think I have anything further to do here. But I have many things to do in here. And here's one of them. This stuff needs to be translated to the new form. See how this goes up to like biquad total rather than just 11? If I am telling everything, like these are all 0, like they're all being zeroed out. And then here I tell it, like, this is what biquad frequency is, or on the other one, this is what biquad 0 is. See the difference? This one's numbered, this one has labels. And because it has labels, you can fit more things in there, and it will always know what to look at. Like if you had biquad frequency meaning something, and it's at the end of the list, kind of like biquad total. If I add more stuff in the middle, it'll still be able to work with biquad total. It'll just end up representing a different number. And all the stuff after the place that I added the thing just gets stepped up by 1, and the program can't tell the difference. Whereas if I did this, I'd have to update all the numbers individually. So that's basically what I'm having to do now, is I need to take this part that says biquad frequency and put it in here, but keep this part, which is part of the original plugin. Because this part is part of ZLowpass, and we're not using we're making it sound like ZLowpass, but we're using this labeling and this way of handling things from ZLowpass. And then we're expanding it outwards because there's a whole bunch of poles in ZLowpass, and ZLowpass has only one. I suppose if I was going to edit or update ZLowpass, I could do it by adding a bunch of poles to it, and then it would be even more extreme. And I'm not even sure what it would do if I added that many poles to it, but it would be pretty freaky, I think. Could be something for a future date. Right now we're focusing on this. So in some ways, I believe, let's see now. So this here, intrim, is actually going to be, let's do things one thing at a time, but see how it says double intrim and it's multiplied by itself a couple of times? That's because this one only does that once a sample buffer. I need to be doing it on a sample by sample basis. And on this one, it's largely the same code. It's the same, like 1 to 10. This also goes 1 to 10. But this one will interpolate it. So this one smooths the motion of the volume control. And we just kind of tack that on to everything else we're doing. I'll remember to bring that in there. But for now, what we're going to do is take all of this stuff and incorporate it into biquad A. So we'll start there. I don't believe this is, yeah, I don't have that check here. That is just for Y. I'm kind of going to keep an eye on what this is doing. And biquad reso is going to be this. And they're all going to copy what they're doing. In fact, I believe that's going to hold for this perfectly well. I can still do that. The D, C, B, and A all wind up being the same values. That ought to still work. I'm going to just double check that. So if I'm using yeah, this is like the up to 7. These are the interpolated ones, and these are the samples, but these are the ones that are being copied over, so that should still work. Zero less than 7, so the first 6 elements, and they all need to be made the same. That should still work, even though we are not using the labels for everything in quite the same way. And then the way this works is we're kind of, let's paste some of this stuff in where we need it, right? See where it says double K in both of those places? We need to make a space here and then use this stuff, and we'll have to change it to say biquad A each time. See, freak, reso, this is a different freak, and reso. I guess I'm going to continue to need clip factor. I'm trying to which of these things belongs to what, right? So some of this stuff belongs to ZLowpass. This definitely belongs to ZLowpass. And we get to the end of biquad reso, and that's what we want. And then this is what moves the previous value in the filter. So I think I can tuck this in here. It has to refer to the same thing. I don't actually have anything biquad in this one, so let's type that in quickly. And that should work with this new program, with the new biquad A that we're using. And then this stuff down here that says double K and so on and so forth. We're going to update this as well so that it looks like this. So that it's got the biquad freak and all of this talk of like biquad A, B0, B1, B2, and so on, because that's what we're referring to. It just needs to be lined up right. So instead of saying biquad A0, it needs to say biquad frequency. Biquad A1 needs to be biquad reso. And then we need to spot each place it's being used. And AB0 goes to every place it says 2, and that's here, and also here, and also here. And likewise, you can see that it's saying the same thing under here. And here's a place where it says biquad A1. If you remember, that was reso. Freak is 0, reso is 1. And in fact, we can confirm that because there it is. And so that needs to be updated to here. And then the rest of these need to be updated to these values. B0, B1 is just underneath B0. B2 underneath B1. See, it's A B0, A B1, A B2, and then we've got B B1 and B B2. This is how people normally talk about the pieces of a biquad filter. This is specific spots that get added to things or multiplied from things. And having done this, the filter ought to be correctly constructed. Now we've got stuff in here like pow factor, which is doesn't exist in ZLowpass. And then we've got this fix A and fix B, and that needs to be updated too. We're not using the same values because the ZLowpass is cutting off at 20K, but ZLowpass actually cuts off with a slight resonance at a little bit over 15K, interestingly. That's how I was able to get it as close as I could to the sound of the actual hardware. You know, whether the hardware claims to go to 20K sampling rate, it's a bit of a moot point because when I had it set that way, it didn't sound right. So what we're going to do is the same that we did previously. Copy these things over to where they're needed. Fix freak is 0 everywhere it is found. It's going to be there and there. Let's scooch this over a little bit. And let's see where we can find. Yep. There we go, 0 again. Fix reso is going to be everywhere I find 1. There we go. As you can see, that is 0.935. That is steeper than simple Butterworth filtering. There's also ways we can tweak that too, but this is what I settled on this time around. So we're leaving that alone for the time being. And fix A1 appears here and here. And then fix A2. Instead of using the number 2, we're going to want to have it be fix A0. I had to talk through this because it can be a little confusing. And then we're going to fit this everywhere. It was just the numeral 2. It's being replaced with this symbol, which means 2 in practice. It's also arranged slightly differently. Then fix A_1 will go in this spot that it's in the 3 place here. Fix A4 becomes this. Fix A5 becomes this. Remember where this one went? A, B0, AB1, AB2, BB0, BB1, BB2. Those capital A's and B's are the interpolation stuff. This one doesn't have it, so it's A0, 1, 2, B1, and 2. And that's what we're about to do. Once we're finished doing this, we're going to build and check and see that it still works. That being a relevant thing, even before we put in the real interpolation stuff, because I believe it's set up so that it will function. Oh, this ZLowpass2 is literally what I'm working on right now, so hopefully you don't have to wait for terribly long. If I'm lucky, I can finish it up by 1, and we'll call it a useful coding day. As you can see, this is one of those for loops. X lives in here, and only in there. And with this one, we're just assigning everything in a chain. Like it goes A equals B equals this. A equals B equals this. And with this one, we'll just do A, and then we'll make all the B equal all the A. And I think we're probably done with that stuff. Might be worth tacking in this trim stuff, though. We've defined it, and we know we're going to be wanting to use it. So everywhere it says in trim, which is up here somewhere. There it is. So everywhere that it says in trim, we're going to want to replace it with, oh, the original hardware didn't even go to 20K. And we don't know what sample rate it ran on either. We're going to want to take this. And so rather than doing it this way, we're doing it this way. So we've already got intrim A and B. Intrim B equals param1 times 10. That's actually the same as what we've got here. And what we're going to find, since this is largely the same function, when we go into the processing, it's figuring out what the trim is, and it's saying intrim equals intrim times temp plus intrim B times temp, and that's where we get this. I am interested, however, in because we do have a change here, I think. Yeah, what we've got here in the original one of this is intrim equals this times 10, same as the other, but we're also multiplying it by itself a bunch of times. So ZLowpass is permitting way more gain. And I think we can do that up here. Let's try. Interim B equal interim B, multiply it by itself in this way. And now it can be smooth, but it is also following that interpolation thing. It's going to go to the same values that the original one does. I'm just going to look in here and check and make sure. Yep, okay, so it is defining that there. But it's interpolating it. And same deal for the output pad. That's going to be in here somewhere as well. Again, there we are, out trim. It's not necessarily going to be param 5. I don't think that's going to be a thing, but instead we're going to be calling it out pad. And the IAR probably doesn't need to be interpolated because that's going to be something very slow. This stuff is sorted out, and if I paste that in there, let's just do it like this. We'll rename this. Instead of calling it out pad, we'll go and find it and we'll call it out trim and we'll handle it that way. But we do need it to be param 3 instead of param 5. We don't even have param 5 in this one. Param 5 is not showing up in blue because it doesn't exist in this plugin. So we're going to change that. And we're going to multiply it by 10 so it winds up being the same as the other. And then we'll kind of keep walking through this until we have it sorted. That should have that stuff sorted out. This wouldn't need to change. Our dry wet stuff is handled by this 4-level affair, which is rather complicated, but does the job. And now we got to go through and handle some of this stuff. Probably, we might have been able to do this overall and just sort of overlooked it. That's fine though. What I'm wondering is whether I can make this be any easier on myself. I don't know whether that's true or not. I think this might just end up being another sort of slow slog through renaming everything, but not quite as slow as you might think, because I don't have to do every single one at a time. Some of this stuff is going to be characteristic. And what I mean by that is they're all separate, but if I figure out what to rename one of them, I can rename all of them. So let's start. We're going to need to find where it says input sample times equals trim, or in trim as it were. This is where that is. I've got one of my little things in where it says if it's 1, then don't even touch it. If it's 1, then it's not going to change, so we don't even do a process at all. But if it's not 1, we change the gain of it. Trim is something else. I wonder where that came from. we're definitely going to have to open up the old ZLowpass and see what that was. But for now, here's some of the stuff that we can do. Long double dry sample equals input sample, which is much the same as saying equals source P again. We could take that. Overall dry sample is going to be the same. And we'll take this stuff up to here. We're replacing long double dry sample. And we're getting up to where it says times equals intrim. So in theory, that ought to work. And one of the things that's happening here is we're defining these things in the way that we need, although we are going to have to edit that. And I'll tell you how. This bit here needs to be taken out of here. Technically we don't even really need that. I'm now questioning I'm not really questioning myself, but these variables are the same each time. That's fine. We can skip this and we'll just assign them. And by that what I mean is, if we've got this, we can start with A. That has to be capital. And then this interpolation code that we've got here applies only to A, and then we just copy them all over to where we want them. And this is interpolating between the two variables, one of which is this buffer and the other one of which is left over from last buffer. We did that here. And then we're just assigning these other things to be all the same, and now we've got them all covered. We don't have to do this for the fixed filter because that's not being interpolated, but this thing needs to be interpolated, so we had to do this and then set them all up. This might be a bit of a CPU munching program, but people did want this happening, and since I have multiple filters rather than just one, I have to assign these values to all the multiple filters as well on a sample by sample basis. Hopefully that'll go fairly quickly. And we are assigning power factor, but we're not going to be using it for this, so let's leave that bit out. And we're assigning intrim. Oh, hello, we did assign. We've got intrim and outtrim, but then this trim doesn't actually need to be interpolated so much. Oh, actually, does it though? Here's the thing. That's a gain trim thing. So remember how biquad A 0 equals biquad frequency? I feel like this also needs to move down here to be proper. This is reference to something that is going to be evolving. So I think we need to move this away from here and down to here. Although we're interpolating the actual coefficients. We're not actually interpolating the number. That's only updating one. It wouldn't do any good. So not so worried about that then. I mean, I could add that, but I don't think it's going to make a lot of a difference. Let's just undo that delete. Oh, I can't. Let's just paste that back in where it used to be. We are using trim, but we are not going to try to interpolate that. It is a very small a reasonably small factor. It is a gain boost factor in here. And these ones are being interpolated They're controls you might automate. This is being defined here and then immediately used here. And this is interpolated. And then this is the gain trim factor based on how loud or what the frequency setting is. So I've actually got that not interpolated, and I wonder if that might be something I would need to add. But we're doing well enough, I suppose. And here we have a place where we could start updating things. Remember how this went 0, 1, 2, 3, 4, 5, 6? I believe that's where this is heading. So the interpolated ones say A, A0, AA1, and so on. This is the smaller ones. These are set up by interpolating between these two ones. So we're going to be using these in the actual code. So, and then 7 and 8 and so on are, it might be worth me referring to the actual guts of the program here rather than, because the thing is, see, we've set this one up so that it's working with this, and that is the same as what's actually in this code, which is the coefficient interpolating biquad filter. So I can take this and make it look exactly like, I can use these numbers and go from here. And this is the stuff that I can copy. So let's just do that. Firstly, I'll grab this and plunk it right in the middle of where I want it. These each are going to be updated into this form. But firstly, this is the bit I'm not going to keep. I'm just copying from it. Except it's a somewhat different format, and that's tricky. So let's see, what are we doing? We've got this rearranged somewhat. So firstly, let us figure out what we're doing. The one that I'm including looks like this. Might be easier to work this some other way. Because I'm trying to take the labeling from this and put it into these, but these look very, very different. Almost like it's a different form entirely. And see where it says SL1? That's kind of how this stuff works. It's like 8 and 9 here. 7 and 8 and 9. See, I don't want to get too tangled and confused to where I don't know what I'm doing and I'm not able to finish it. So let's go bit by bit. Let's figure out what this is. Anybody who is a complete newbie, I'm joining you on your level. I'm confused enough about this that I don't know how to do it. So what we're going to do is examine this stuff here. This is the interpolating one. We're not so worried about the fixed one. Those happen over here. And the entire way that this is arranged looks and feels entirely different, and that's a little bit perplexing. Maybe what I should do is look into the numbers I've got here and look into my H file. Yeah, save that. We'll be editing it more later. And just kind of run with this. So here's my H file, and this is the stuff I'm going to be using. So if I start typing in numbers here, I will have a reference for what this thinks it is. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Although that is not actually, so here's what's tricking me up this time. I can do that, but it stops making sense because I've included all of these which weren't in the original one. So let's maybe try to think our way out of that. That's not going to be a thing, but what existed in the original form, and the original form is how this worked before I started interpolating everything. Original form looks like this. And the way it's set up, I believe I am in fact using the one where it says L1. See, it's got 8 and 9, and 9, 10, and so on and so forth. Before I was labeling them, this is a biquad formulation that allows you to do stereo, but you don't have to. So you can keep counting upwards. It's only counting up to like 9 and 10 and stuff, but I think it originally went to like 11 or more. Let's reopen this again and see what it actually was, because this is what we were working from. We count up to 11, and let us take a moment and look at ZLowpass in VST format and see if that number is different. If that number is different, that tells me something. So here's my VSTs. This is the original ZLowpass. And if I open this one up and look at where the stuff is defined, see, I started including the ones that go all the way to 15, and this original time I went and did it, these are only as many biquad parameters as they need. But the current way of doing it is the one that counts up to 15, because then you can just port it directly over to stereo things like VST more easily. So what we're going to do is try to make sense of this somehow. I probably will be able to make sense of this somehow. I got about a half an hour before the stream is usually over, so we will just see. Firstly, let's close everything. Okay, close everything, settle down. Let's see what we're looking at. Here's the one I'm trying to build. This stuff is going to be comparable to what the original plugin was made like. So if it was numbers, it would count from 1 to 8 or 0 to 8. I remember seeing those numbers. And then I'm going to be looking at what in this is SL1 and SL2. It's not going to be including these, I don't think. It's not going to be interpolating, so it's not including those. And we'll just dangle this over here and open this back up again. You're definitely going to have to bear with me because this is not creative block. This is a complicated, convoluted process. But the great thing is, if I can get through this, then the subsequent ones, I'll get to refer to what I did here. And that'll simplify things a lot. Although the making it VST is still going to be a bit of a bear, but... So there we are. We've got the interpolating biquad filter here. And these are the ones that we want to edit. And these are the numbers that they should correspond to. So what we can do is a little find and replace. And we're going to walk through this bit by bit, at which point we should be able to get to an end and have a working result. You know, it's possible that we'll get to the end so well that we'll have a working result that's already done, but failing that, we will at least have a nice solid start on things. So this stuff we need to edit. I don't know why this says biquad A9, because this doesn't go to 9, does it? I do know that fixed streak winds up being 0 and reso equals 1, so biquad A2 is going to be biquad A0. And let's also edit this, because we know that L1 and L2 are 7 and 8. So L1 and L2 can be 7 and 8. This is the one we're going to be trying to copy. We're going to have to figure... Oh, hang on. I begin to see some of what's going on here. Ha-ha! It looks a little bit like we're copying from the stereo. That's strange. Could that be? Is that a thing? Let's quickly have a check on that as well, because that would explain a lot as to how messed up and confusing this all became. So if we open up the AU version of ZLowpass, is it in fact actually a stereo? In which case I've got a lot of work to do. Open up CPP. The way I'll find that out is by looking here and seeing whether there's stuff relating to stereo. Get property info, get that, get this, reset. Doesn't look terribly much like this needs to be a stereo plugin. Oh no, I don't think I found the guilty code. I think I'm still a little bit hosed, but we'll see. This is the getting stuck and grinding for hours until you get through part of the process. And we can start some of this. I'm going to say so 1, 2, 3, 4, 5, 6, then 7, 8, and then 9 and 10. That would imply that I've set this up in such a way that it has those extra parameters in here. I didn't remember it that way, but clearly things are a little ambiguous here. All the rest of this should be working fine. So now it comes to whether I can make this stuff work fine. And I always know biquad 2 is going to be by A0. See, the way this works is this one replaces the number 2, and this replaces the number 3, and this replaces the number 4, 5, and 6. And then the remaining ones, I figure out what I'm doing with regard to the stored samples in there. And I'll probably refer to just these characters here, and we'll just see where we get. We'll start with the ones that we know are going to be a certain way, like biquad A, 2. We know that needs to be biquad A, bic A, 0. And that shows up there, and seemingly only there. But we're also going to do biquad B the same way, and so on. And I believe we can replace that, and then we're going to go through and do B through D exactly the same way. C, and D, and we're going to have to step through every single one of these this way. But you'll see why shortly, because there's only one of these, but some of these other ones show up multiple times, and you will see that as well. So that was by A0, 3 becomes A1. We have only one of those. Again, we'll walk through A through D. P. Still seems good. Oh, got another comment. Sampling rate is a broad-ranged question. As a bandpass source with band limited. Well, my DRes plugin does in fact use frequency truncation and aliasing in its frequency calculation stuff. There's stuff like that you can use. I could also do something like that in a way that's similar to how I do the downsampling, the undersampling. Let's keep going. C. And again, if I get this working, I can copy this resulting code into the subsequent ZLowpass or the Z2 filters. It's just this one, it feels kind of like I'd better walk through it bit by bit. Replace the C. This is absolutely mind-rotting. But sometimes the work is not fun or inspiring. Sometimes it's just, you can figure out what to do if you take it bit by bit. Here, this becomes biquad A2. Some people would automate these things, and there are ways of doing that. And I wonder where. I think I got it, though. We'll find out momentarily, because biquad B hasn't done. Yep, okay. C. Pretty soon we're going to get into the ones that appear multiple places. Those are the ones where you don't want to miss one, because these numbers could have nothing to do with the labels. If I put in something in the beginning of the enum, everything would change, and then everything would be broken in really confusing ways. And that's why we use enums. That's from Paul in the search synthesizer thing, is he was advocating for that kind of stuff. And I believe that took care of D. You can see in this code here that now it's going biquad A1 times biquad B7. That's because 7 and 9 and so on, those are the, yeah, I've got like 8 and 10 and 9 and God knows what. So these come from Actually, I'm wondering what the hell I was doing here. I guess we'll find out. Let's just do them and see where we get. Because if I was just defining stuff, I'm sure I'll be able to figure it out. But if I'm just defining stuff, then if this is labeled wrong, it would probably still work, and then I could figure out what I was doing with it later. 4, okay, so we'll go to 5. 5 is B1. And as you can see, that's tucked way along here. We've got a whole bunch of stuff going on. I'm a little mystified by it, but I guess I must have a different form in here somehow. That or I think I might know what might be happening. I think I might have some kind of like interpolation or something going on that's not part of the actual biquad filters. Like I'm using extra stuff in here that's not really part of a real biquad. I guess we'll find out. I'll find out when I try to make a VST out of it, is what I'll do. And I'll be doing that by looking at how the VST for the low pass is constructed. I could also look at, well, no. The VST is going to have this. I can see that it's left and right already, so the VST is going to simply have this. I think what's happening is the filters that I'm using here have extra stuff built into it, but I built them in custom. So these things might need to be changed. But I think they can be changed. We will get through this. We will get through this somehow. So biquad A5 becomes B1. Here's where it's going to do its work, and that's how that works. And same for all the others. My apologies for how brain rotting all of this is, but I have to sit through it. This is sometimes what the job is like. I'll try to keep being chatty and all of that kind of stuff to the best of my ability without losing track, because losing track would be terrible around about now. And I think we will solve what's going on with this before I'm done for the day. I'm very interested in why this is as perplexingly unlike a biquad filter, and it's not matching up with my other biquad filters, because it's kind of supposed to be a biquad filter and matching up with the biquad filters. So there's B1. I've gotten all the way through to D and 6. B2. And there we are. See, this stuff at least, this is straightforward. This is working. I can make sense out of whatever madness also is here later. So far so good. And again, I have to do 4 separate polls of this because this one has 4 polls to work with. I'm also curious as to whether it's going to sound interesting when sweeping it around at its maximum resonance. Because the Z-plane style one, we're not doing increasingly high resonances in order to make it do its thing. We're adding more poles to make it do its thing. And then here's D. There. Now while we're at it, we can also, yeah, see, this is perplexing the way this works. We've got it saying 9 and 10 here, but the way I had it sorted out, there's also an 8 and 7, and that's rather baffling. I don't know what the hell's going on here. Maybe it's some kind of funny smoothing thing, or maybe it's just a different form. I don't know. Maybe if I drank about 12 more cups of coffee, I'd be able to sort this out. But same deal applies here, probably. Fix A0, 1, 2, and B1, 2 are going to be these numbers, so I have at least this sorted out. And then the rest of it, this is the only place that 9 and 10 could make any sense, so we're kind of in the same boat here. We can use this same numbering system. It just doesn't make any sense to me. We'll delete that off of there and go by these and just rename this stuff and walk through the same process again. Hang on. I'm struggling with biquad filters.
Are you on your live stream?
We're live.
Okay.
I have somebody with me. But she's being very good in letting me work. And so I get to share this time with you struggling with biquad filters. Yay. This is how much I love you. Look at what I'm missing. So, fix D needs to be changed into something. So we're going to rewrite these. Fix A, capital. And we'll go back and do the other ones. And we're going to walk through the same process from 0 to 6. I know it took forever. I can't help that. But instead, fix underscore, I believe it's a freak I'm looking for. Yep. So instead of BIQ, it is FIX. And that should be the correct one. Oh, yeah, well, this needs doing what struggle? I don't think you can help. I am struggling with coding ZLowpass2. And if I succeed in doing this, we'll have the coefficient interpolating low-pass filter that will have a more smooth blend, but it'll be the sound of the EMU sampler that it's supposed to model. And that'll be very cool. Trouble is, the way it's coded seems very weird and complicated and twisted up, so I'm not making a lot of sense out of this, but if I can make it function, that'll be a nice start. I don't know whether I'm going to get there, but all of this stuff is up and working and ready to go. It's just a matter of, like, this is all updated. This is what it needs to be going forward. These are fixed, so that's fine. These are copied over much like it is here to where I don't really need to have this in two places, do I? But maybe I do. Or maybe what I just did here was useless. So let's see. No. What I had there was not useless, but what I have here is. So let's see. So biquad A so yeah, instead of going up to 7, this needs to go up to what? Let's fix this bug before dealing with the other bug. Yeah, because this is wrong. Guess what? These are the things that are interpolating these early positions, but then I have to actually also interpolate all the way up to here. Or I have to assign all the way up to here. Like biquad D has to, well, or no, wait, no, hang on. These are all going off of biquad A. this is being defined as biquad A, which we're working from. I believe we never need to do this at all, because it's assigning what's actually these parameters that are the result of the interpolation. So let's see now. And we're working this all on biquad A, and then we're assigning all of these from the end result of what ended up being biquad A. So essentially, we never actually need to calculate out these parameters for any of the other ones. They can all sit around being 0 for all the difference it would make, because we're assigning this stuff all the way down here in biquad A, and it's not being touched for any of the other ones. And then once we're finished doing that, we're interpolating always from only biquad A as an example, and then assigning this early stuff, including the very first resonances and things, always from biquad A. So I never actually needed to do this at all. So we'll delete it. Like, that would have actually run, but I would have thought that I needed to do that. And that is actually not true. This also needs to be updated. The other stuff, not so much. Okay. Well, let's get back to this grunt work. We need to update these things if we can find them, or find what they do. Yeah, I haven't had a lot of luck with adding feedback on nonlinearity. So this stuff seems legit. And this stuff seems to not actually... Yeah, so we're only using these interpolation things in here. This one, we're only using the interpolation things in here. I guess we're still on track. So we're not actually turning that up anywhere except for... No, we're not actually turning that up anywhere at all. When we skip beyond 0 and 1, oh, no, that's a 10, so that does not count. That would be a nice way to get into big trouble with the other one. I wonder whether that happened. Let's find out. No. If I had gone biquad A bracket 1 and matched that and then replaced it with biquad reso, it would say biquad A, biquad reso 0, and would be totally broken. But it looks like I managed to avoid that problem that time around. Let's avoid that problem again. For some reason I just started with 2, and these are the ones I have to start doing. So fix A0. And thankfully I don't have to do as many of these, and when I'm done, I'm done. 3 is A1. It's so tricky keeping track of some of this stuff sometimes. 4 is A2. You might not be able to see it, but it's still on the screen, kind of, sort of, hidden under the chat. 5 is B1. 6 is B2, lowercase, of course. Now let's do that over again, but with fix B, and then we can start grappling with what on earth these other numbers are doing here. we'll go back to 2. There they are. And 2 is A0. That being the label for what you normally call that place in a bytecode filter. And then same deal. 3 is A1. 4 is A2. 5 is B1. 6 is B2. Well, I mean, the way that I stumble across redundancies in optimized code is a very intuitive process, but this is me at my worst with it, because this requires a lot more comprehension of how this stuff works, and that is sadly not very forthcoming. However, I do know that I can take what I've got here, SL1, SL2, SR1, SR2, and sort of run with this and make a fixed frequency thing. And that might actually help me understand what's going on with the regular filter, because these are the fixed frequency filters, so this should behave itself a little bit, be a little bit more normal, be a little bit more like what I wanted. That said, I don't know if it's going to be or not. It's acting a lot like something more is going on, and I don't understand what it is. This is messy. Let's go back to fix A for a moment. Seven will be SL1. That will be sample left 1. You see there's multiple instances of it here. That's because I'm having that be input sample. We're doing kind of a little chain of these samples. It feels like this is a different arrangement for the biquads than I was expecting. And the trouble here is we're doing these long chains of the samples, and what I'm doing here doesn't make any sense. So let's continue stepping through it. See whether it's any better once I'm done. Because this is supposed to make sense. This is supposed to make sense. It makes me very sad that it does not, but these are the kind of jams I get myself into. And at least some of this can be walked through fairly quickly. And 9 will be SR1. Would be R2. So as you can see, what we're doing here, something is going on when we have a biquad filter that's using 2 parallel channels where it's not supposed to be. And that is very strange to me. This is part of the op-amp stage, so there might be something special having to do with that. In particular, I might have better comments on this in McAdee, because the op-amp stage came out of McAdee. I might have commentary on why this is. However, I'm going to go through the fix B section and figure out what's going on. Because, yeah, I might have simplified it, but McAdee might have more commentary or just something to explain what's going on. Meanwhile, I'm going to want to quickly step through this again. Capital L, 1 for B7. That should be replaced with a number or a shortcut thingy. It's being replaced with this thing. 9 is going to be R1 unless I find something better to call it. You can see it's in several places, but what it's doing is it's copying the one thing, and it's keeping little delay chains, and I don't know why it's keeping little delay chains, but that's most definitely what it's doing. And then lastly, 10, well, not 910, but 10, is going to be SR2. So now this is all the same as just using numbers for them, but it's been stepped forwards to using the form that has these labels where you can see what's going on. Thing is, this is not how that's supposed to work. This does not bear any description. Like if I go to, hello, why are you doing that? Let's not close that then. How about, like if I go to something where this is, and I look up what it is written as, this code's going to look totally different. It does say df1, so I can test that assumption by doing exactly what I just said. Let's open up ZLowpass. Here's the same thing that I saw here with the fix and so on, long double. And if it was coded the way it's supposed to be coded, it would be looking like this. Looks very different. And this is calculating the coefficient, so that part was fine. And so if I have this, I can copy this and just not keep it permanently. This is what it's supposed to look like if I was doing it that way. Why is it that the output stage, we do have like fix A and fix B. I can make a little space under here. Why does this look so different? Firstly, let's replace outsample, or temp with outsample. And we're going to pretend that we've got this in here somewhere. And that should make it be kind of similar. So how is this different? This stretches out way over here, says df1. We do not seem to be handling things in the same way here. We really don't. It says fixed biquad filtering ultrasonics, but this is super different from what I have here. Just keeping two little chains. Maybe I'm doing it elsewhere. Maybe this is direct form 2. For the op-amp, do I use integrator and differentiator with nonlinearity? Well, let me see. Integrator is basically like it's your IR low pass filter kind of thing. I've also seen those represented as some programming language thing, which escapes me right now. Lerp, interpolation, lerping into something. And so the integrator is trying to filter stuff, and in so doing, that would be here, IR sample A, and this is not doing nonlinearity. This is providing a high-pass filter. It's a very gentle high-pass filter. Oh God, excuse me, I'm unplugging. I just ripped the cable. I ripped the power cable out. Let me put the power cable back on. Bear with me, guys. This is one of the tougher streams I've done. Differentiator, I have no idea what you mean by that. You got to rephrase that, please. What I need to do is find where df1 comes from and sort out what's making it do that. Because this is acting like I'm doing multiple filters, and the one I've got here is made in a different way. It's almost as if one of them is a stereo filter and one of them is not a stereo filter, and is handled very differently. So let's see, this is the one, this is the other. theoretically, I could simply replace these. I could just punch these in, but I'm fascinated as to what on earth is going on here, so I'm going to find out. Because this is from MacAU, Macity. And for that reason, this is the analog model. I got to find out why it's doing this. I can't just replace it with a straight biquad filter, because if I had something special in Macity and I undo that and revert to a plain old biquad filter, I'll be losing some of the tone. And we can't have that. So I have to work out what was happening, what was different. And hey, this looks exactly like the one I'm grappling with. DF1, and it's organized exactly the same way. So let's see whether we can get any kind of information on, like, is this meant to be a stereo? Could that be it? I don't see a lot of sign that this is a stereo processor. In fact, source P and des P, these are still mono. So what we've got in Macity is this biquad A and biquad B, and their low pass filters. And this direct form 1 okay, all we've confirmed is that this is exactly the same as what we're seeing here. So this is directly from Macity, but I believe it is still a normal biquad filter. Let's take this apart just for a moment, because I really would like to. It's the kind of thing where, you know, if you find a fence and you're like, that seems dumb, I don't understand why this is here, therefore we're going to delete it. It's like, no, you need to find why it is the way it is. Only then can you delete it. It's the GK Chesterton fence problem. And so I'm running into fences. And so this is how this biquad is handled, and this is direct form 1. These are all of our statements from here. And this is a big chunk of stuff being added and manipulated too. What did I do in Macity when I had a stereo Macity? Did I simply do left and right versions of that, or did I do more or something else? I can go and look and find out. I did biquad A 15, so it's not just 11 entries. So with this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I needed more entries. So this is not actually going to serve my purposes. This doesn't support direct form 1. This supports another form of biquad. So what I've got in this one, see, we're walking through this bit by bit. This is how this kind of stuff is done. It may be not pretty, and I may look like a complete bozo, but sometimes you got to do the thing even if you're a complete bozo. Get to the end, figure it out. And I know that now that this is another form of biquad. I think what's going on here is direct form 1 is doing all the calculations together and keeping these two little delay buffers. I believe this is the other form of biquad that I'm looking at, that this other stuff is designed to work with. I think that's what's going on here. So, that has consequences, several consequences. One of them is, and this may also affect the other stuff, but we'll burn that bridge when we come to it. I think we can solve the fixed biquad filter problem in the end. Basically, if we can establish that biquad direct form 1 is the same as this other biquad for all practical purposes, that means we can do the Chesterton-Fence thing and remove the biquad direct form 1 and replace it with this other form, which doesn't need as many variables hanging around. And if we can do that, we can do stereo versions of it when I do end up doing the VST version. And once we've done that, we can start digging into the 4 poles of active filtering that go on. So, this is my copy of what's right up here, which I commented out. That's direct form 1. It requires keeping these 2 little sample buzzes. Oh, Jess, oh honey, I'm never going to be able to follow what you're talking about. Maybe somebody else in chat will. I'm in far too bad shape to follow that, Jess. There's no chance. But I am in good enough shape to do this, I will tell you. We want 2 filters. We know they're biquad filters, they're just different forms. We know that this works as a biquad filter, and if we comment that stuff out, that is now working, and this is a formulation where I can make it be a stereo version fairly easily, which apparently was not the case the first time I went around and did this. And when it says fixed biquad filtering ultrasonics, I'm going to want to phrase it in such a way that it's using outsample, which we have defined elsewhere. All right, if we haven't, we'll find out really quick. And we're taking this code that is another form of biquad but should still work and poking it in where this form lives. So same deal. And then see how this all says fix B? This stuff needs to say fix A everywhere it appears. Forgive me for being very slow with the typing. My brain is kind of leaking out my ears here, but it's a thing. And that should be also a biquad filter. So it replaces that because it can. It's just a different form. And that means the output stuff ought to work. Then the next problem we run into is this. It looks kind of like this is that original form, but I'm not absolutely sure. I feel like maybe that form is I'm puzzled as to how some of all this works. I've replaced this one. Direct form 1 was not my friend there. let's look at how this is implemented. This appears to be a similar deal. This looks like the other form that we've swapped stuff in on, and this looks like direct form 1. So if that is direct form 1, here, let's compare them. This is a different biquad, but all the same, if this stuff is confusing me, and this is just a gain trim, and this is direct form 1, this is still part of direct form 1 here, I believe. Well, like it needs to have this bit in here, biquad A equals outsample after everything else. So that's equivalent to this, and then, but without the clipping, because the clipping is happening inside this bit. Now, if we were to do that differently, here's the question. Can we clip in the same place using this other form rather than direct form 1? And that's a big question, seeing as the whole thing's confusing the hell out of me. So, here's how that's kind of shaped. This bit needs to be tucked into the middle here. It's the clip stage. This is the boost. We don't need to worry about this. This is the blend. We don't need to worry about that. And where do we fit this in here? It's possible that we don't. I need to identify where in this point is. Because you see this form of the filter, it only uses SL1. It only uses what's going to end up being like 7 and 9 here. Whereas direct form 1 uses a different arrangement. It's like it's using 2 little sample buffers, and this other form doesn't use that. Although my concern there is we were able to do the fixed filter using this other form. My concern there is that I can't use this new format for, well, but can we though? Like if I was going to use the interpolating filter and open up, like the Y filters work just fine, I just didn't have as many instances of them. Let's see how those are shaped. I don't need to look into the VSTs for that. We're going to dive back into the ZLowpass. We know that's going to have the correct configuration. And that's the fixed filter. This is all the interpolations and stuff. And this is the guts of the coefficient interpolating biquad filter. It happens inside these things. So we're basically handling it very differently. But we're talking about the difference between this here which is equivalent to what we've got there, Except for, let me take this back out again, because I didn't have that there, did I? So the way this was shaped was kind of like this, and the other ones look the same way. And I spread this out, so let me put that back as well. And now these look the same. This looks like direct form 1, but there's the thing chunked into in the middle of it. Oh, Jas. Oh, Jas. Showing me numbers and code again, Jas. You mischief maker. You realize I'm twisted in knots over this one. There's no way I can think about what you're typing. Oh, Jas is being... You know, I had a troll on my Airwindows site. There was a fellow from, I think, Thailand or something, who was just typing, oh, I'll never be able to follow that, Jas, not in a million years. I will never be able to follow what you just typed. Try me next week. So, this is what the Y stuff is doing. This is also a interpolating filter, but this is the kind of interpolating filter that doesn't use as many variables and where I've got it defined in such a way that I can make it stereo easily. I'm pretty sure that what I've got in the Z filters is such that it's not at all an easy thing to just punch in these keywords that I wanted to do, because I've got an entirely different form. Like the words in here, like biquad SL1, biquad SL2, those no longer correspond to what I'm dealing with in the direct form 1 filters. That's what's happening here. And so the fixed frequency one, I started trying to swap in these, but the fixed frequency one requires another set of delay variables in there, which is not part of my design. And since it was a fixed frequency one, I could just swap it out, because those are not unusual filters. But the Z-plane style ones, these are more unusual. These have a clipping factor built into them. And what I must do, oh look, I've copied and pasted it twice. That's nice. That, or I just got it from elsewhere. This is exactly the same as what I have here, so let's just... All I've done here is I have tightened this up a little bit. I clearly have a clip factor in there. I've got to keep ZLowpass exactly the same as it was. I can't be making a mistake in changing it, because it would change the sound. I need to make it coefficient interpolating, but it's a different form of biquad, so I need to translate between the two. And here is what's going on. As I go through this, we have input sample going into the filter. This is the filter that we're coming from, where it has to match. This is the stuff where I'm going to, where I'm trying to make it work with this form. So we need to make this form work the same way. And this stuff, it's input sample, dry sample, and so on. All of this is part of the this stuff is part of where it needs to go. It's part of the dry wet thing. It's part of the polls. I don't have to worry about that. That's going to be easier to handle. And this is the only part that concerns me as far as how direct form 1 works. And this is the clip factor. And if I'm not mistaken, everything else here is exactly the same. So the job here is this. Here's how direct form 1 works. It's this one ginormous pile of stuff being added. Here's how the other form is. Maybe it's the indirect form. I don't know what they call it. it's doing things kind of in parallel. It's making a temp, it's doing this. It does actually work, but it's using only these left values, and it's calculating the 1 level things and subtracting level 2, and then calculating level 2 at which point it's done with doing that stuff. So I need to figure out what this 8 and 10 and 7 and 9 mean. Let's explore that maybe. Because what we're kind of looking at is A0, A1, A2, B1, and B2 probably. We've already got those represented. Well, we can find similar places with some of these things. So let's just start breaking this down. I'm not sure this would actually compile, but and the addition and subtraction is commutative, so direct form all shook up ends up becoming a thing like this. Look how it's kind of looks like it maybe makes sense or something. So biquad times input sample. And what this other form does, oh, now this is not my favorite form of filter, Jazz. Now this is becoming my least favorite form of filter in the whole wide world. Specifically, I don't have to know how all of this works so much as I have to know where to put in this term. Because the whole deal here is, if the way this filter is made to work, you put a clip term in where, like, the feedback part of it distorts. And there are experiments that we could do to try to make it work. Like, here's an interesting thing to note. Check this out. Temp equals input sample times biquad SL1, which is one of the saved up samples. Now we make L1 be something, and we bring in L2, and then we make L2 be something, and we're using temp every step of the way here. With this, A0 times input sample, or input sample times this, these are the same. So temp is going to be much the same as outsample. In fact, let's edit this. Might be a little easier to work out what's going on in the guts of the biquad sample if I do that. This is our feedback pole. No, I've looked at multiple different implementations and I'm trying to make it be exactly the same. I have to understand how the guts of the biquad filter works in order to make this happen, so God only knows how long this is going to take. So here's how this works. This in the parentheses is the same as this in the parentheses. They're reversed, but multiplication is commutative, so those now look the same. Addition is also commutative, so biquad SL1 is what it was last time, we're only updating both of these things every step of the way. And A1, A2, B1, B2, those are coefficients. So kind of what we're looking at here is this is adding this while processing that. And we're adding these things and we're subtracting these things. So I feel like the way this is arranged might be kind of like this. Because the adds and the subtracts are just in a row, so you could scramble them and they would wind up being the same as long as you do them all in a row like that. So it amounts to being kind of the same as this. These are each stepping along. I don't see where we're assigning by quad A. No, I do see where we're assigning that. So here's the deal. Here's how this actually works. So to do the Airwindows Z form thing, this is how this works. We got in sample and out sample. Out sample is defined as pretty much just what you're starting with, but also adding this stuff. Then 7 and 8 are the chain of things that are it's the delay line pre-biquad filter. This is the delay line on just the input. It's the delay line on the output that we need to clip, and we need to clip it immediately before it gets pumped back into the filter. So we need to do this clip, and it doesn't have to be called out sample. It could be called anything, as long as it gets used. Because the whole way this works is we get out sample generated through this, and then we have to clip it before funneling it back in. And we have used it before we clip it. Like, we've used biquad A9, but biquad A9 is from last sample, not the current sample. So we are clipping it before we do this first calculation. And the first calculation is B1. Oh, hey, we have B1 in here somewhere. B1 lives here. So outsample times B1. This must happen before we clip outsample. And then as we go further, here's B2. This must happen before we clip outsample. But then the next thing, then when you next, let's see now. So clipping in the between here. Outsample 9 equals outsample. So we've got that. Then we've got outsample, and then we are clipping not the first but the second delay stage on the output of the biquad filter. So biquad A9 becomes clipped, but we've already calculated it, and then next sample it's going to be, and then 10 was made to be 9 before that. So basically we clip before, because see, this is the other form. And we're doing this, but we have just reassigned, no, have we just reassigned? No, we've reassigned biquad A9 equals outsample, which is the result of all of this. And only then do we clip 9, and then 10 becomes 9, which is now clipped and kept for the next sample. So we're doing some calculating, with a 9 that's the previous sample other than the one that we're using, and which has been clipped. So what outsample from here, but see, this is a different form, so we don't have by quite a 9 there. Oh my. It's like one of them's in series and the other one is in parallel. And I don't see how the one of them is in series and the other one is in parallel. So how this works is, well, one thing we've got is here. This is plus biquad SL2, and that is left over from here. So we're using this before applying it. So SL1 is this various stuff from SL2, and somewhere in here it needs to get clamped to negative 1.0. Well, there are experiments that I could do here that could get kind of messy, but might be worth doing. Because here's the deal is I have to include this clipping term in here. If it is not in the right form of the plugin, then I have to find a place to put the clipping. If I don't have this clipping term in here, it's not going to sound like ZLowpass. It'll be something else. And I have a different form, so I don't know where it goes. And in the direct form, input sample enters into this part and this part. Like 7 ends up becoming input sample, which is just raw. Like you have to apply this to the previous term, but then you take the raw input and you start making 7 and 8 be the direct follow-up, whereas the output sample is the one that gets a clipping term in it. In this form, we have input sample, and that doesn't get touched, and that's being added to this bit. So A1 times 7 and 8, that's how we incorporate this delay. So outsample is the place where we clip, but we need, like with direct form, right? What we're looking at is this big pile of text. It goes from here, and then it starts adding all this stuff, but none of this is actually saying outsample, right? We're generating this, but we're using everything that doesn't actually say outsample yet to do it. But then when we go through all of that, we do this stack, and then we do this stack, but as soon as we assign outsample to biquad A9, we immediately clip it, and only then do we allow 9 to carry through and copy it over to 10. So 9 and 10 are both clipped. So if we have to, and then let's copy this. Actually, we don't need to copy that, do we? We just need to grab it, because I don't actually have to change it, because if I'm not mistaken, here's the one where this must get clipped. We're working with input sample here. We're working in a chain, and if output sample must be clipped at every point on this by the time you get to the, well, there's the question. So if it's able to work with itself and apply its filtering, and then apply the additional layer of outsample, outsample gets clipped only once. It sounds like outsample could be clipped here. If so, then this would be the form in which it was used. We would be clipping outsample before it gets used in these places. And we've got the continuing form going on, plus this is how the other form works. In theory, that should sound the same, and that might be enough for me to walk through this and try this form and then edit it so that everything coming up is in the right place. Let's see. I'm just tidying that up. I need to soothe myself and tidy up the comment there. And let's see, SL1, SR1, that'll make it easy to do stereo versions when I need to. So now we put this back because we may just have recent through it and figured out how it worked. Let's make it look the same. That's where the clip lives. And then if that's how that works, I'm not sure this is how this works, but I mean, this is the experiment we're doing is, will this actually result in the same sound? If it does, we're home free. If it doesn't, I'm in a big pile of mess and won't be able to use my templates for this. Huh, it did for the ZLowpass. Oh, I don't even know, man. Goodness gracious me. So one thing I know about this is, see where it says input sample equals output sample and where I've got a clip? And see where it says dry sample equals? Let's grab this too. And in theory, I can put this stuff here. And get rid of this and leave that there. And I think I had it in, yep, I had it in 2 stages. So see how these look together? How they look about the same? In fact, I can even rephrase this just a bit, I think. So input sample clip factor, very good, very good. I'm going to need to update the versions of these. No. Oh, honey. I am so obviously not talented. I clearly don't know what I'm doing, but you could say the most persistent. Because one thing you could say about me is I may be incredibly stupid, but I don't give up easily. And I have a sense of what needs to happen, and that's important too. And the bottom line is if I use my ears to get the tone of this right, and the struggling through this stuff that's not really my forte results in something that still sounds right, then we win. Then we got it. I do know that the coefficient interpolating stuff is right. I'm just trying to adapt it to this other form out of the form that I was using for just fixed frequency stuff. We are on what might be some kind of right track. So what I'd like to do now is see how all these things are like dry sample equals, this is my blending stuff. This is the stuff where I know where it goes. This is the stuff where we start with a little boost. And this is the stuff that's that direct form one. And by the way, anybody watching this, if you want to start learning to code and so on, you know, you can do it too. If I can do it, you can do it. See how this looks kind of the same? How it looks rather simple and similar? And see how that says, let me double this up a little bit. I'm making it be a specific thing here. So we got that. And the reason this is phrased the way that it is because this first one always applies. And so I had it a little bit simpler by just assigning everything in a row, but it's the same as what I've got here. What I've got here, bquad 9 equals output sample, that's the same as these forms. These forms all match this. Oh, except for I gotta move this over here, but that's no biggie. Now they all look the same. And the deal here is if we can get this to work and then place this modified version where it needs to go. Like, see how it says input dry sample equals input equals output, and then these ones are all dry equals input equals a blend between output and dry sample. And that's how this blending stuff works. So there's the chunk we're replacing, and this is what we're replacing it with. Let's actually take this comment out as well. So in theory, this could replace this. And if this could replace this, then this could also replace this and this and this. We've broken out all the bits that need to be on opposite sides of that algorithm. And in theory, it would work even though the clipping stage is up here rather than down here. Like with this, the clipping stage is down here. And it's a completely different form of the calculation, but we may still be able to get through. So I would say my next job here is, let's start copying and pasting. This all says just biquad and isn't really a thing, but when we paste it into this and then add the relevant letters, we should be able to comment out the stuff that doesn't relate. So here's our first level. Actually, you know what? We can do this. So if we comment this, or copy this, working out from first principles whether direct form 1 is the same as whatever the hell else this is. And if I paste it, it won't be commented out because it has to sit between those two things. And then paste it under here. And same for each of these. B, C, D. And then go through, and these are the things that need to be commented out now. So and I can do that without deleting them entirely. I do have to warn you, if this doesn't actually work, I will have to stop. I don't have all day for this. We could come back next week if it comes to that. And there's A through D, and here again, this is labeled direct form 1. This is what I copied from. So I don't need that there anymore. And now what I've got is the, oh, I know. The other ones are A through D. I have to type A through D in each one of these in the right places. However, that is fairly straightforward. I can walk through that fairly quickly. The question is more, is this going to continue to clip? Because I've got everything else sorted out, and we're going to find out. We're going to listen to this one compared to the original one and see. So here is where I will tuck some of these in now that I know where they belong. going to leave just a little bit of a space, but tighten it up just a bit. For shits and giggles, I'm going to tighten that up too. It's commented out, so there's no harm in it. I don't want to take it away entirely until I know this works, because if it doesn't work, then I have to go back and work it out. Oh, sure says SM58. That's doable. You can do that. Yeah, I don't know that much about MK4. I do know that the Roswell Mini K47 is very nice. I'm quite happy with that. Also, I've recently discovered a Rode MK1. Very, very, very low noise. Amazingly low noise. But let's walk through this. Like, this is important, and also I don't have all day here. So, A. And then all of these also have to be A. And I'm super interested to find out what this did. I am more interested than you could possibly imagine to find out what this did, because this is like dark magic for me. If I missed one, then it will just fail to compile, and I'll go and fix it. There's B. This one's going to need to be C. Yep. There's the clip factor. There's a clip factor for that one, and then D. Also, a nice thing about this is that since it's stacked up so much, oh, and I know I missed a couple up here. Since it's stacked up so much, if it is the same, I should notice. If it is not the same, I should notice that. We'll just crank it way up, and we'll see where we get. And in theory, that should be it and cover everything. So let's see if it builds. Ah. So we don't need to worry about that, I don't think. But we do need to sort these out. Where's outpad? Outpad and overall dry sample. I believe this is out of the original ZLowpass, and I should be able to sort out what was missing, but I'm heartened by the fact that the rest of it worked. So we need this here. That is no mistake. In fact, we could continue doing this. We'll just take it from the raw output. And that needed to be there, so that was one concern. And I believe that some of my concern was having to do with the fact that in trim and out trim, unused variable. Ah, see, that's what it was. In trim and out trim, this is what I assigned these to. They're interpolated. The original one is not. And so what we need to do is tell it, hey, out trim is what you want to do here, because that is smoothed. And now we may very well be able to build. Goodbye ZLowpass, and here's our new version. So this becomes a thing. How are we doing? A little testing here. This is ZLowpass. Let's also set them to exactly the same while we're at it. Not frequency, but and we'll make that 0.3. Let's make it a little louder. Let's make this be 0.32. We'll just compare everything. So this tone, that's ZLowpass. I think something's wrong, guys. Okay, so that super didn't work. We're coming on to 3 hours of work and got nowhere. Let's see whether there's an obvious reason for that. I doubt it's up here at the op-amp stage. So it'd be in here somewhere then. And I hear some kind of fan roaring away like mad. I'm not exactly sure what's going on there. I wonder, I just wonder, it's making a note. I don't know why it's making a note, and it's not changing with the frequency, and that's even weirder. Although I can make it go away with dry wet. So here's the thing. Can I comment out the clipping term and have it work? Like in theory, if I comment out the clipping term, maybe it won't be completely screwed. Let's find out. I mean, it is compiling at least, so we've got that going for us. So, ZLowpass2 again. That sounds suspiciously like not a thing. Weirdly, why am I hearing a note but the rest of it, I can still hear what's going on? So, what else is happening here? Could it be the high pass? Or the filter? Let's see what's happening here. Maybe it's the filtering, in which case the other stuff is okay, and that would be somewhat reassuring. And filtering ultrasonics and the clipping stage in there. And we'll comment this entire chunk out. And then if we do this, is it going to go me or not? Yeah, the fixed oscillation is weird because it's like, why is it doing that? Why is it doing that? Although that'd probably be a simpler fix if that's what's causing it, because I'm basically trying to, the hard part is getting these active stages, the sweeping stages to change. And I was hearing them underneath the buzz. So what do we got now? Okay, that's alive. The buzz was something else. The buzz was in this output stage, and that should be easier because I knew how it worked before, and it's not that complicated. It's just something that I'm missing, so that's cool. But this is not distorting. So what we're going to do is jump back into here and uncomment out the stuff that I previously commented out. I may also be missing something somewhere. Like I got to look for bits that I didn't include. That would explain a lot. So, distortion factors need to be put back in each step of the way to see whether it does anything or whether it just blows up. Distortion factor is back in. And it feels like this part might actually have worked. We've got a distortiness, and it sounds like it's in a place there somewhere where it's not super different. The part that I'm failing at is the filtering afterwards, and that should be pretty straightforward. So the question is, what's going wrong? And it's going to be something real obvious. So it's time to compare this directly with the other one. Or indeed, we can go bit by bit. Look, there, now we have a just regular old high-pass filter, and we can see whether that made it do the thing. If that made it do the thing, there's very little that I need to fix. I just need to find out what's going wrong there. This is a debugging process of figuring out what changes. Thank goodness I don't have to reboot this machine before I try again. Do we have our note? Nope, so it ain't the high pass. That stuff's commented out, so it shouldn't be a concern. How about the distortion part? And now we have only the filter part, but we have a distortion factor in here that shouldn't be doing a note all by itself. Let's see what it does. Bit by bit, we are trying new things. Wish I had another copy. Well, I have a bottle of water. I don't have another cup of coffee. I'd be very surprised if this suddenly started to honk. Okay, something having to do with the ultrasonic filters is not in order. Everything else is fine. All of this. Although I'm hearing some clicking on the poles, but I'm not sure there's much I can do about that. This is smoothed. this is smoothed. And it's kind of sounding cool. This is sounding like what it should. But those weren't the honks. So we now can track it down to something going on over here. Could I have made typos? Fix A and fix B. It appears that those are all updated to say fix B. It appears that these all say fix A. This is that other form. What do we got here? You might want to keep plugins that are made by actual smart people, but I do make interesting sounding ones. Aha! Our culprit. The question is it both of them or just the one? We have an additional one over here. Does that do exactly the same thing? In theory it should, but I'm obviously missing something. So we're going to find out. Let's see. Do you also make a honky noise? Totally do. Alrighty, something having to do with these ultrasonic filters is super screwed up. This ain't right. Boy, ain't right. So we're going to try to see what the heck is going on here. Although we could simply take what's here and use that. My only concern is that it'll work, but it's messing up everything. And I do not get why this is doing what it's doing. Oh. Do you see where it is? I found the problem. Did you see the problem? Big round of applause for whichever person sees the problem, because it's not that big of a problem and it is fixable. Do you see what I see? Do you see it now? This started out being called temp. Here's my code. Here's this. Up amp stage. This started out being called temp. So what we need to do to make this work is, if we're using outsample, it's all got to be called outsample, including this bit here. That's the cause of the whole problem with that. And this should just work. Now we find out whether it sounds the same as the other one, which I do honestly hope it does. Although honestly, if it sounds more like the real thing than the previous one did, I'll count that a big win. This has been a wild journey with a very silly man with a good ear and a dream. And now, here's that first one. Then here's this one. This was a ride. We got there. Now let's go back and forth a little bit. I would like to open those up in an effect stack so that I can hear them in succession. So let's do that. First ZLowpass and then ZLowpass2. They're set up exactly the same, and we'll just turn them on and off. How about? Here's the one. Here's a new one. You know what? I think the new one is closer to the real thing. Listen to that. That sounds a little more open. I'm not getting quite as much of a sense of it. And of course, since this is coefficient smoothed, alrighty. Folks, we're going to call that a day. This has been a long one. Thanks for bearing with me through all of this. And let me just shut down my stream. And thanks everybody in chat for being so clever and doing things. And hang in there with me while I try to do this stuff. Suffice to say, I think we finally got there. So, goodbye chat, and I'll talk to you folks later. And this is not going to come out on Sunday. I don't think. You'd have to beg me. But, yeah, we got there. Laters.